The building envelope is where we have the opportunity to reduce energy consumption for both heating and cooling. Building performance is about controlling heat, air, and moisture flows to provide comfort, safety, and health for occupants. The building envelope is the most permanent part of a house. Choices about insulation levels, air sealing techniques, window and door characteristics, and exterior finishes are crucial to the durability, longevity, and long-term affordability of a house.
The most cost-effective ways to improve the building envelope are air sealing and insulation. Air sealing stops heat loss via infiltration and exfiltration. It's always the first line of defense when it comes to energy efficiency measures. An effective thermal envelope reduces the flow of air between inside and outside, slows the movement of heat, and controls the movement of moisture at a reasonable cost. To do this, the envelope has to have the following: a weather barrier, an air barrier, carefully installed insulation, minimal thermal bridging, a vapor barrier, and in cold climates, drying potential to the exterior.
The job of the weather barrier is to keep liquid water that has leaked, penetrated, or seeped past the siding or cladding from getting into the exterior sheathing or concrete wall or further into the building envelope. This barrier is often building paper on an old house, but newer houses may have a house wrap or a membrane instead of traditional building paper. Ideally, flashing and caulking are used in combination with the weather barrier to create a continuous drainage plane on the outside of the building envelope. A weather barrier acts as the skin of the house, keeping rain, snow, and wind out of the living space. Adding a weather barrier also improves energy efficiency by eliminating complications from wind and water penetrations inside the wall cavities, in attic space, and inside the foundation after they've been draft-proofed and insulated. The weather barrier must create a continuous drainage plane to take rain and melting snow from the roofs and walls and direct it away from the foundation. In some cases, the weather barrier can double as an exterior air barrier. From a building science perspective, the building envelope needs to have 3 key items to perform well: a vapor barrier, or vapor diffusion retarder, to keep moisture vapor that's inside the house from entering the wall cavity, an air barrier to stop air, and a thermal blanket to reduce the flow of heat transfer from inside to outside. These can be 3 separate materials, or a single material that functions as 2 or even all 3 control layers. Out of the 3 layers in a building, the one that is key to the success of a wall assembly is the air barrier. It controls airflow, and by doing that, it also controls water vapor movement. According to the U.S. Department of Energy, air movement accounts for more than 98% of all water vapor movement in building cavities. Stop the airflow, and you stop most of the moisture flow. In addition to stopping the flow of moisture, one reason air sealing is important is because it prevents unwanted air leakage and pollutants from entering the home. A good example of this can be seen when looking at garages. The air sealing details between the garage ceiling and the living space over the garage are critical for 2 reasons. First, depending on the pressure regime in the house, there is often significant heat loss in the living space, driven by infiltration and exfiltration. Second, air transfer between the house and garage can expose occupants to carbon monoxide and other pollutants from vehicles. The role of the vapor barrier is to prevent warm, humid air from moving into the building envelope. It is in place primarily to counteract moisture diffusion, which is water vapor that moves through materials. The vapor barrier is not required to be taped and sealed. In fact, it's usually in fairly bad shape by the time strapping, drywall, and services are installed. The key aspect of the vapor barrier is where it sits in a building assembly. In cold climates, the default position is on the warm side of the insulation, or with at least 2/3 of the insulation outside of the vapor barrier. A better thermal envelope decreases the rate of heat transfer through the opaque assemblies of the building and can be combined with an air barrier and continuous insulation level. After improving airtightness, increasing insulation levels becomes the most cost-effective measure that can be taken to improve a home's energy efficiency. Every time the R value of a wall, floor, or ceiling doubles, the heat loss through that element is cut in half. This means that the ability of insulating materials to retard heat loss follows the law of diminishing returns. As insulation levels are progressively increased, this approach will reach a point where other methods of saving energy may become more cost-effective, such as the use of better performance windows and high-efficiency heating equipment and appliances. The initial benefits of increasing insulation levels are significant, but become less beneficial as higher levels are reached. Computer-based energy modeling can be used to predict the energy use and energy savings that could be gained by using increased insulation levels relative to other energy efficiency measures, which helps to optimize the overall costs of high-performance housing.
Sealing a house up and not paying attention to the impact the air sealing has on indoor air quality, or the need for additional mechanical ventilation, can lead to serious problems for both the occupants and the structure. As well, tightening up the envelope of a house with any fuel-fired space or water heating equipment can lead to combustion spillage. So it's important to do depressurization testing to detect potential problems, most of which can be avoided by installing a makeup air duct or combustion air duct to bring in outside air. Or, where feasible, replace open combustion appliances with sealed combustion equipment. Current industry practice is tighter equals better. The building code requires mechanical ventilation to provide fresh air to the occupants and